Section 1.5, number 14. We're given three functions. F of x equals absolute value of x, g of x equals the absolute value of x plus 3, and h of x equals negative 2 times the absolute value of x plus 2 minus 1. And we're asked to graph each one of these things on a standard Cartesian coordinate system. So let's draw that on here. Okay. Now, f of x is absolute value of x. This is a nice even function. It has a slope of positive 1 for the positive x values, a slope of negative 1 for the negative x values. Okay, and it goes through the origin. 0 is 0 like that. G of x is x plus 3. So we are taking our x, our input, and adding 3 to it, which means that things happen sooner, which means that our function moves to the left by 3. That's the only change that happens here. So we're going to take our 0, shift it to the left by 3, and draw it in just as it is. All right. Now, for the next one, there's three things happening here, right? We're adding 2 to the x, we are flipping by the negative, and we're scaling by 2, and then we're shifting down by 1. Okay, so we shift left by 2, we go from the origin to 2, right? We go negative, right? So everything that's above the axis flips down. The 1s happen at 2s, right? And then everything is shifted down by 1. So instead of going through 0 at 0, we go through negative 1 at negative 2. We're going to have, instead of a slope of positive 1 to the right, we're going to have a slope of negative 2 to the right. Instead of having a slope of negative 1 to the left, we're going to have a slope of positive 2 to the left. Okay, so if we look at what's done with our function here, right? Our 0 point got shifted to the left and then down, left by 2, and then down by 1. Okay, our positive 1 was shifted to the left by 2, down by 1, and then scaled by negative 2. So instead of being 1 up, it is now 2 down from that point. Okay, so the negative shifts, the 2 compresses, and then the negative 1 shifts down. Okay, all right, and that is how these things work.